I'll talk about how to plot graph. We call it graph plot, basically data plot, and nowadays people call it data visualization. Okay, so the package we'll use is matplotlib, mathematical plotting library, and I will depend on Numpy, sometimes SciFi, sometimes pandas, which I have not yet introduced. Later on, we will introduce pandas, lots of things. Basically, what we want to do is that we have data, lots of data coming from somewhere, or we are generating data in experiments or from sampling or etc. etc. And then first we want to see what the data look like, what are the relationships, etc. etc. from the visual thing. Okay, so I will go step by step how to plot your data, how to see. Okay, so first I minimize this. I go to idle Python because I introduced on the first day. I introduced this Python idle, and here you can what we have to do is that you have to import matplotlib, that is the package, external package. Under this there is a module called pyplot, pyplot. Pyplot basically does 2D plotting, two-dimensional plotting, XY plotting, and we can give a nickname as PLT, right? So that's it. And what I have to do is that you can check, you can go to dir and check what is there, PLT. So you will see there are lots of, there's a huge, pyplot itself is a huge module, and there are lots of other things in matplotlib. So you can see lots of, if you can read, first function that we will need is that plot. Where is plot? P, it is coming alphabetically, P, yeah, here is plot. This is the most important function that we will use. You can understand plot is for plot, and you can go there, you can, oh, I'm sorry, I accidentally, these things, deleted that. Import matplotlib dot pyplot as PLT, then, okay, then PLT, under that there is a function called plot. So we have to call it PLT.plot. That is the function, right? So let me see what is there. Help. So dir and help are the two functions that you will always remember wherever you go. In Python, these are the only two things which will be always useful, and you can explore yourself. Help, you have to give the reference of the PLT module, and you have to write plot. Okay, so you see squeezed because it is Python 3. Okay, so you see lots of, first you will read that plot, and then there will be arguments, and then all these things will be there. These are the keyword arguments and so on. And then there are the examples, lots of examples will be there. Lots of it itself, it is a huge, these things, huge description. Is a lot of things you can do with this plot function. Of course, this is the most fundamental function here. Okay, okay. So here I come. So to begin with, you have to do is that first you have to give to data XY data. You need some X, say for example, give it any name. I'll just reduce the size. Okay, so X is equal to say 1, 2, 3, 4. It's a list. You can give another list, say something, say 5, 6, 9, 11, whatever. So 2 lists. Already, I think ADG and A, they have introduced a bit of matplotlib when they taught their things. So you know the data should be the X and Y data, the length of X and Y data should be the same. Otherwise, you cannot plot it. 1 versus 5, 2 versus 6, 3 versus 9, and so on. And the data can be given as a list or a Numpy array or a tuple or anything. Okay, so now you write plt.plot and then you write p x comma y. That's it. Okay, so the plot is created, but on interpreter it won't show you automatically, and the created and the memory address is there. It's a hex code. You see, it's started with 0x, but you have nothing to do with that at the moment. You can understand the plot is created. Okay, now there is another function called show, plt.show. Okay, so you just write that blank. Okay, inside you can write something, but you need not. Okay, moment you do, the plot is created. You can see the plot. Okay, so the first few things I can tell you. The plot first, if you do not say anything else, you can actually do a lot more things. You can design the plot, your plot. You can present your plot the way you want. But if you don't see anything, don't tell anything, then the plot will be with this blue color. That is default color, and the thickness will be like this. This is thickness, the default thickness, and the plot. You see 1 point here, 1 point here, 1 point here, and 1 point here. But they are connected by lines. So if you don't see anything, the lines will be connected by. The points will be connected by lines, continuous lines, and the X label, Y label, title, nothing it will tell. So it will give you this bare graph. So that is the beginning of the beginnings. Okay. So this is, I want to, there is your first graph. Okay. Now, better I switch over to Anaconda, because whatever I will do today will be recorded there. So that I can give you the file, like Orunabha did yesterday, I can give you the file. So I go over to Anaconda. Okay. So people who are doing on interpreter can do this. Whatever I'll be doing on Anaconda, you can do it here. Okay. Okay. I can remove this. So here is my Anaconda Navigator. Let me tell you first, if you go to Google, some people are asking how to load Anaconda, how to do with that. So if you, I think there are some disturbances. Okay. Please put off your audio. Please put off your audio. Check your audios, please. Okay. If you go to
Atish Chakraborty, please turn off your video and audio, please.
Can I continue?
Yes, you can continue.
Okay. So just a beginning. Whoever are using Anaconda is nothing but a distribution. It's a distribution with basic Python. It means core Python plus several packages like Numpy, SciFi, Pandas, matplotlib, and a few more, which will be useful for your data science and your machine learning things. But normally, if you are doing very little things, you may not even go to Anaconda, this navigator or so. And you see there are lots of platforms are here, which you have already know. It is IPython console. This is Jupyter Notebook. I will use that. Okay. Then Jupyter Lab. Then Arun Habada used the Spider. Here is the Spider. And you can see lots of things. I will use Jupyter Notebook today. Right. If I click here, launch, and the Jupyter Notebook, it is already opened because it takes time. So that's I already opened. So you'll see that this is opened in your browser, whatever browser is set in your browser. So I'm not launching it. It is already launched. Okay. So now I click. Where is this? I think, yeah. Let me check. Let me first check. Yeah, I think here. No, not here. Also, it is. Let me check where there's another browser. So machine is new, I think, today. And let me check. No, it's not. It is not. It's here, but okay. Yeah. No, it is not there. It is not there. Let me hold on, please. Well, what can I, where can I go? No, no, not here, not here. Here it is. No, no. Sorry. It is. Okay, let me go again. Let me launch.
Abhijit,
Let me launch
Abhijit,
it again. I think, where is that? It is
Abhijit,
coming.
just a
Oh,
moment.
it has come. It has come.
Abhijit, can I
Oh,
is your idle plot is still alive?
yeah.
Just open this idle plot. I just want to show you some, just the
It is
idle
not.
plot.
It is not
The plot that
alive.
you created with
It is not.
idle.
It is not alive, but I can create it again because I
Just,
removed.
just,
Okay,
just it's
just.
fun. I'd like to show
Just,
them.
okay. Import matplot plotlib, because I won't use idle anymore today, so that's why I
Yeah,
didn't.
but there is one advantage of idle plot.
Okay, yeah, there are lots of advantage of. Okay, and you can see 1, 2, 3, 4, and then say 5, 6, 9, 8, 9, whatever. Okay.
Okay.
Okay, and then plt dot show. There are lots of advantages of lots of things. Yeah.
Now you just now you drag the cursor in the bottom line. You can see, you can read the data.
Yeah.
That is something you missed.
Yes, it's like origin software, right? You can read the data. Yeah, this is the beautiful thing of advantage of interpreter. Okay. Yeah.
Well, that's actually available in almost everything, including GNU, for example.
You can do
Almost
it
everything
on
does it.
Jupyter Notebook also. You have to set something.
Yeah, by default it is
Correct. Yeah, Jupyter Notebook actually doesn't. You find
but
it
it is. I always prefer interpreter because it is easy to begin with, and for people, I mean, there are lots of menus here. You can go back and things like that. You can zoom. You can save it directly from here. Lots of things are there. So interpreter is very good. But for today's talk, I will actually prefer the Anaconda Jupyter Notebook. Because I want to save all these things, whatever I will be doing, and then so that I can distribute it to the people who want to use. By the way, since you have told, we have used lots of softwares for plotting in life. Many of us. This looks like Origin software, came in Windows, but it is paid actually. And there we had lots of advantages. And then in our whole Linux life, I think is the most favorite of Anand also, ours also, we used in our life, that is GNU plot. So it's open source software, you don't have to buy, and it is online with your working on your command line, you can give it. It's a very fantastic software, very fantastic graphical software, open source. But still, I will prefer matplotlib because since we are doing Python, so we will later know that we are surrounded by Python. We do not have to go out of Python. So in whatever we will be doing today is basically Python program, but we are writing in terms of some commands that is coming through the packages, from the packages. Okay, so that's what I want to emphasize. Okay, so I just kill it. Okay. So let's go here. If you click the Python, the Anaconda, if you click the Jupyter Notebook, so this will come on your browser, and you go here and you open this one blank sheet and you begin to type. So let's begin from beginning again. So import matplotlib.pyplot as plt, and you see you run. It is the shell is running. This is first shell, and you can write x equal to say 1, 2, 3, say 4, and now you write y equal to say something, say 4, 8, 16, 24, say for example, and you now plot plt dot plot and x comma y. So this is you run, and the plot will come here itself. So it's like in one sheet it is coming. You can call it inline. So plot is coming in line, okay, and it will show these things. If you want to, sometimes if you want to get rid of this, you can write plt.show here, then it will go. It won't show it again. Okay, so this memory location address for etc. won't show it again. So this way I will create the whole entire sheet. So this is I talked about. Okay,
You need to increase the font size a
increase
bit
the font size
in the view.
How do I do this? Do you know in these things I tried, but I can from my
Abhijit, it is Chrome.
I can
It is
do it
Chrome.
from
Yeah.
hand. I
It is
scroll, huh?
Chrome. So just beside your face, just go to the top bar. Beside your face, there are 3 vertical dots.
Beside
Click
my face.
in the top bar.
On top.
Okay.
Click that. Now you have zoom here.
Zoom, no?
Zoom. Zoom.
Zoom.
You can do a plus minus.
Okay. Great. I generally do it with control plus, control minus. Okay, anyway, and with my laptop, these things also, pad also, I can do it by hand. Okay, so this is the minimum size I will do. It is okay. Is the minimum size, or I'll reduce it a bit. Otherwise, sometimes you can see that it is okay.
No, it's okay. It's okay. I think.
It's okay. Okay, so I'll continue with this.
And one thing, Abhijit, one thing, the advantage of using Jupyter Notebook is you can have multiple sessions at a time, right?
Right.
Multiple cells.
Yeah, multiple cells. Yeah, it's all this shell, this one shell, and also you will see lots of things. There should be one full lecture, 1-2 hours lecture on Jupyter Notebook itself, Anaconda Jupyter Notebook, because you can do lots of things. You can go this way, you can in between, you can create a shell. Say you can create a shell, you can take it up there, you can write say something. Okay, you can take even up. You write, say this is our matplotlib session. I'm writing this this only, and you go here the code and go markdown, and also you go here ###3#. It depends on the size, and then run. So the headline is prepared. If you give 1 hash, it will be huge. It will be 2 hash. I mean, the more you put hash, the lesser it will be the size. Okay, so you can write LaTeX commands here, all these Greek symbols, everything you can do. So you can combine LaTeX with these things, and so you can this way make your whole presentation, make your own book here, everything, and also the file. This will be created. You can see where you can see this. I have not saved it. I'll save it. Let me save it. Save as, say, matplotlib demo, for example, and save it. You will see the matplotlib demo is saved, and the file. You will see the file. Here you can probably see the file is a IPYNB. Interactive Python notebook. So it's a different style of file, and I can give it to Ornabada gave this file. You take this file, you put again, you run this from your Jupyter Notebook, it will be live again. So that's the advantage. You can transport this file anywhere. You can immediately get to see things. Okay, so that's the important thing. Okay, so next is I don't have to tell it again that these XY the data, you can give it like a list. If you even could give it like a tuple, it could also work. If you could also give it in the form of Numpy arrays, also work. So you need some pieces, 1 2 3 4 1 2 3 4. That's it. So this is as simple as that. If you remember these things always, so you have to import matplotlib. This is a package. Under this, there is a pyplot module, which is for 2D plot, and you always nickname is PLT. You can give it any name, and then the rest of the things are just follows. Okay, so now you can little bit design. So plt.plot, you can see, you can write x, y, and you can dictate, okay, I will give it with I write hyphen and O. That means I don't say anything. It's a keyword argument actually. Keyword I don't need to give because it appears after X and Y in the if you look at help file help, and if you look at help of plt.plot, you can see everything. Okay, so you discover yourself. So hyphen is the continuous line, and O is the bullet symbol. So if you run it, so it will plot with the bullet. Okay. Okay. So you can now go on doing this. Now you try to decorate the plot. So you can write a lot more things. You can go to PLT and see lots of functions are there. Only some handful of functions that I will talk about today. PLT dot figure figure. This is the beginning. You can give it a figure name here. You can give the some number here, but okay, for one figure it is okay. You can inside that you can give a keyword argument, fixed size equal to, say, I can give you say 12:8. So that means the fixed size is the ratio is 12:8. So this, if you do that and write say PLT dot, I create another right thing, and we get X and Y, and we can explicitly write color. We can give it now color equal to R for red. You can write red, but it is not necessary. You can write R. You can write here C for color, but for the beginners I write color equal to red, R for red. Then you can write also line style, what I have used above, but I have not explicitly said what it is. And I can give it say minus, so separately. And I can give you marker, which I combine both of them. I can give you O. I can give you O. That means bullet. I combine these two things in the same shortcut. Then probably you can give then probably you can give MS. MS is marker size. MS equal to say 16. Let us give and see what is the size. Then you can understand what is the size, what is what. And then you can give line width. You can control line width, LW. LW is whatever the default, it will be 4 times that, say, for example. And also you can put a label. Label will come later when we will create some more things. Say I give say temperature. Say temperature. Okay. So you can, it's a long line, you can break it. So you have all these things. Suppose all these things. X, Y are essential. This will plot, and these are not non-essentials, but you can create on your own for your decoration purpose. Color, line style, marker, MS is marker size, line width, LW is line width, and put some label. Okay. Next, you can also plot X label, PLT X label. Okay, first let me first, without this, first I write PLT dot legend. Legend, okay, and I don't give anything first. First I see that this bare minimum things. You plot with the styles and the PLT dot legend. Legend will talk to this level. We'll put the level at some place. Okay. Now it run. Let me run here. Okay. Let me. I think I have to reduce a bit. Otherwise, you cannot see on the whole entire screen. You cannot see my screen is not enough. So you can see it, right? So this is the level, temperature, right? Maybe I can put it bigger again. So this is the temperature, and see, this is the symbol is line with this bullet, and I have not told it to put it here, but I can dictate it where it will put. Okay, and this is line is now thicker, red, bullet's size is 16 point, and so on. Now I can put some other things, like I can put X level, PLT dot X label, and I can give it some name. Suppose say x-axis, right? And you can write it, say size equal to say 20. So it's a 20 point. Normally, if you see, if we write in 11 point, maximum 12 point, but in the normally we type, so it's a 20 point, much more than that. Okay, 20 point size. Okay, and now similarly we create plt.y label and say give it y axis. Notice a few things. The names are to be, of course, will be is a name is a string. You have to put it between two inverted commas. And of course, you can see, check every different functions. Figure is a function, plot is a function, legend is a function, x level function, y level function. All the functions are there in PLT, in pyplot. So you go there and check what are the things, how you can manipulate every function the way you want. And you write size equal to say 20. Okay, so it will put x level and y level. Also, I want title. It will write something on title, title, and similarly, title is title. The names are very kind of, you can understand. So each name corresponds to whatever you think should be. So I can write, say, this is my first graph. Okay, you can write that, and also you can give size equal to say 20. Okay, so size equal to 20. And now also you can write on top of title, you can write another title. So you can write plt.subtitle. Subtitle means super title. Okay, title over title. So I write say figure 1 and with inverted comma. And after that, I write say little big. I give some little respect, so it is 22. And okay, well, this. Let me see first what it does. Okay, so I'll reduce it bit. Okay, otherwise it will. Oh, so this is the figure 1 is subtitle. This is my first graph title. This is y level it is written, this is x level written, and so on. Now I go here and increase. And now I can write even something more, like I can write PLT. I can set the ticks, x ticks. You can play with all those things. I just tell you the names. You can do it a better graph than I'm doing here. And the graph is say it is showing automatically from 1.0 to 4.0. So you can write it say in a list. You can write where you want to put a tick, x ticks. So you can write 0, 1, 2, 3, 4, 5, or you could put it as a range of 5. That would also do, but I wrote explicitly. Okay. And the y ticks you see it goes from something here below 5 to 25. So suppose I want to write plt.y ticks, right? So I want to put except some 0 there, 10, and then 20 and 30, not anywhere else. Okay, so x ticks, y ticks. So also you can control the tick parameters. So there is another function plt.tick underscore params. And then you write say what parameters you want to control, x-axis parameters, tick parameters. So axis equal to you write x, and you can also label color equal to say green, for example, and then you can give label size equal to say 16 and so on. So now lot more things we have done. So now you run. I hope what pltx ticks add 1, 2, 3, 1. Oh, I'm sorry. This is what is said. Has not. Oh, x ticks. X ticks should be there. Oh, I'm sorry, I did a spelling mistake. I did a spelling mistake here. So I run. Okay. So you see the x-axis. You see the ticks are here 0, 1, 2, 3, 4, 5. On top of it, I control the sizes of the ticks 0, 1, 2, 3, 4, and the colors. You see, I have written here level color. Level color is G for green. You can give it anything, and the level size is 16. And the only X parameters I have controlled, and Y parameters I have Y ticks only I have given, but the parameters I have not controlled. So Y ticks are whatever the small size by default size it is there. It is showing you. So this is something that you can do. You can do a lot more things. Very many different kinds of things. For example, you can also title inside the title. What is title? What is the title? Here is a title. What is the title? Here is a title. Inside the title, you can also give a dictionary, a keyword dictionary. Dictionary you have learned already from ADG and A's lectures, and you know dictionary is a kind of is a unique combination of two things, keys and values. So this is very useful to while we write programs and manipulate things. So here also you have a keyword font, F-O-N-T, font dict. There is a keyword called font dict, if I am right. So equal to, you give say font name. You can choose the font name. So font name you have to give something in a in inverted commas because it is string. So now you can choose font name, and people who have done in words, they see that you see that in the drop down menus there are lots of fonts. Some of the fonts you can these fonts are used here, so you can actually remember some of the fonts. Once upon a time, my favorite font was Comic Sans MS. Let's see whether it takes. And also you can create font size. Instead of giving size here, you can write font size equal to say not equal to, right? It has to be, you have to write a colon. If you write colon, and you have to write it as a colon, right? It's a dictionary, not equal to. Okay, so this is the font name is the key, and the value is Comic Sans MS. Font size is the key, and the value is 20. I now omit this. Okay, now I omit this. Okay, so here it is. So the title you have control with this font dictionary. Let's see what it happens. Yeah, you see this is my first graph. If I can increase the bit here, you can write say 26 so that you can understand better. So this is the font counts. So this way you can actually control lots of things. It is only a very small things, very little, only a very few things, but they are very common. The plot is the most common. You have to put label, of course, X label, Y label, title. These few things are very common. Then comes ticks, parameters, control, and everything. So this is your first graph. Okay, so now I go over to something. Okay, I can now show you how to control the legend. Here is the legend, right? Where was this? The legend was here. I did not write anything here. Sometimes it writes here, you see. Sometimes you wrote here. So I can actually write some keyword, say location equal to 2, and see where it writes. It writes here. I can write location equal to say 1. It writes here. I can write location equal to say 0. It is writing here. 0 also writes. 0 is the best position, I think. So let's see, write 3. So here, how do I know? Sometimes it writes. How do I know? You can actually take type help, and then you can write plt.legend, and you can run, and you can see read this documentation, not all everything is important at the moment. I will go here, right? Location string, location code 0 is the best, upper right is 1, upper left is 2, lower left is 3, and so on. So you can get to see from your manual, inbuilt manual here. You do not have to write anything to anyone. Okay, now I introduce the arrays. I'm actually creating a fake data, X and Y, the lists. Now it is better to go over to Numpy arrays that you have learned by heart so far. So after Abhijit's all brilliant expositions. So now I will use Numpy arrays. Numpy array is the most important thing. I can tell you all kinds of people here from basic science, from outside basic science, and anywhere. So Numpy is the most important package, external package in Python, the single most important package. Lots of packages are developed over Numpy. You see the SciFi is developed over Numpy, scientific package. Pandas, which deals with structured data, that is, and the Excel sheets and etc., that is developed over Numpy arrays and so on. So Numpy is the most fundamental package, data handling fundamental package. So and especially Numpy arrays. If you know how to control Numpy arrays, one-dimensional, two-dimensional, particularly two-dimensional, and then three-dimensional also sometimes, and then you know you are with the game. And the other for visualization, I found that matplotlib is the most important plotting package. There are many other packages developed along with it and to assist it, and developed with it, with the help of it. For example, you will see PyLab is a package. So it is with matplotlib's part of the thing, like pyplot. It will take the pyplot, two-dimensional plot, this module, and also it will combine with Numpy arrays. So it will create another package which is called PyLab. You can actually import PyLab also. You can also see things. Then people who will be doing data science, you can see there are the packages Seaborn, S-E-A-B-O-R-N, S-E-A-B-O-R-N. Seaborn is another package. We won't use it today, but it will give you some very fancy plots because in the professional areas, industry, people like to see very fancy plots. Whatever it is there doesn't hurt. The matter is important. The presentation is very important. So the many fancy plots are done by Seaborn, based on developed over matplotlib. So these things are there. Okay, and there are many others. Okay, now I will use Numpy. So I have to import Numpy as NP. The advantage over of doing on this this Jupyter shell is that whatever you did, all these commands here, that will be there. So I don't have to import matplotlib again in a new shell. This is a new shell. Import Numpy as NP, and suppose I Numpy, so I don't have to introduce. So I want something X equal to, say, for example, np.arrange, and I can write, say, 0.5 and 10 and 0.10 and 0.5. So it will create numbers from 0.5. It will go just before 10, and the step size is 0.5, right? And I want to plot a function, say y equal to, say, suppose I want to use some function. Say, for example, np is the package np.exp. Exp is exponential. You go to Numpy and check. There are lots of mathematical functions are there. And of course, again warning that the same functions you will get it in math library, math module also, but the differences are emphasized again and again by ADG and AA, that the functions here and functions there in math module are a different kind, because here in this function you can take an array or list or whatever, because you can take a collection of numbers in math module. the function exponential or sin x or whatever sin or something, there you will take a single argument, but you can take at least or array. So if you done, that means the functions here, exponential is, this function is vectorized. Vectorized means it will operate on each of the elements. Okay, so that is the thing, remember always. So that's why the other day our friend asked that why I will not import from NumPy import star, why I will not do. Anando explained that it is one problem, that if you import everything, one thing is that your space is cluttered, and the other thing is that the functions you have Dhalafai here, the function may conflict with the functions in math or something like that. So that is one thing. Okay, so x and y, and then you write plot, plt.plot, and x and y. Also, you can say as a new thing, you can add with plt.grid. You can add a grid also. You can like it looks like a graph paper. So you do it on a graph paper like that. Looks like a graph paper. So you can also, you see the grid is a function. I won't go in detail. So you can control the grid size, grid line, the color, type, dashed. Grids can be dashed. Grid can be more densely packed. Grid can be the thicker lines, etc., etc. So you can control grid. You can control plot. You can control all the functions going there inside. So this is something. Okay. Now we create. We can write now our own function. For example, suppose I now write, say, if you want to plot your own function, for example, like you know how to define a function. Define, say, fx, and now you return, say, x starts as 2 minus x, right? So that way you created a function, right? You created a function. Now you can plot, say, for example, you plot, say, function plt.plot. If you write this, let me check, x and f of x is your y. Let's see whether it plots. Let's see. Oh, it plots, because it is not vectorized, but is it should be vectorized. But one thing is that x is your NumPy array. That's why I'm saved. Otherwise, if x is a common list, it would not do. Okay. So anyway, now well, this is with your own function. Now we can write, say, x equal to np.lin space, and you write 1, comma, say 10, comma, say, like I want to plot a sine function, 2 star np.pi minus 2 pi, then 2 star np.pi, and then say 100. I create 100 points. Okay, so this is your x. Now you want to plot plt.plot, then x, then np.sine, and you write x, and you can plot with red color. Okay, let's see what it plots. So it is a sine curve, and it doesn't look good. So I give a plt.axh line. Ax line is again another function. You can get it from the name. Ax is axis, h for horizontal, and line. If I don't write it anywhere, anything, so it will draw a line in the 0 here. So now you write this, and also I write this plt dot show, so that it won't show these message every time. So okay. So now, so you see, and also you can control the color of the line, width, etc., etc. This is horizontal line it is drawn. It is your sine curve. Okay, so you can also plot, say, for example, you can plot, say, for example, say y equal to np.lin space 1, comma 10, comma, say, 100 points. Okay, and not y, x, And here you write, say, y equal to x. You don't have to write function for that. X cube is enough because this is a numpy array. It will automatically take care of that. It is already vectorized. So if you write plt dot plot, if you write x comma y, and say, for example, I create certain things with some line, and say with a symbol like this, triangle, it will create a triangle instead of gola. And I can also plot with say plt dot plot, not plot, plt. There is a function called log. You know, whoever know logarithms, you know the log means it will create log on both sides. Then there is a function called plt dot semi log y or x. Okay, then you will be function of plt dot semi log x, y. Yes, of course, not all we will plot. So you can now check. So this is, see, this is x cube, and if you would not give this, it would plot like this. And if we give this, it will plot a, obviously log means it's a straight line. So now you can use the funda of Numpy array. So now you see x and y are Numpy array.
Abhijit, if we have multiple number of y sets, multiple number of y values.
Yes, madam. Coming. Lots of things. I haven't only 10%, 0.1% of what I wanted to tell. I'm going very, very slow.
Okay.
I'm going very, very slow because I understand at the background that people are actually typing on their computer. And so that's why I'm actually going slow. Sorry. Okay. Yeah. So this is, so you see, you understand this x and y are Numpy arrays, and you see lots of data here. Suppose you have plotted lots of data, and the data are actually here plotted on top of, because this is log scale. So one is like on the others, superposed as if. So we don't want all those data. So what I will use for my beautiful plot, I can actually slice, and the slicing I can do here only. I can say, suppose I can plot x, and I can write colon, say 5. So I will, you have understood, right? This slicing technology ADG has taught you. So this nothing is written means it will begin from the beginning. After 1 colon, nothing is written means it will end at the end. And the step size is 5. That means it will jump 5 indexes. So if I do here, I have to do it here also. Colon. Otherwise it won't accept. Yeah, because the size. So now the slicing has been done. So you can do the slicing, and you see the data are now the less dense. So you can now present in a better way. So you see the log scale here, and I have not decorated all those things. You can decorate it here. So this way you can do lots of things. Okay. Another interesting thing I can show you, since you have heard about, I don't know whether Anand, I'm unfortunate that I could not attend Ananda's talk yesterday, Anurana's talk. I was out of station. I wanted to desperately attend, but I came back home late, and in between on the way I saw on the road I saw certain ways they were doing brilliantly, but I missed whether Anando has introduced SciFi or not. Probably he had, but even if not, I'll just use the SciFi package just to show you. From SciFi. SciFi is scientific Python. SciFi, and people who are in physics or in electronics, they often do with signals, different kinds of signals, like the electronic signals like square wave, sawtooth wave, etc. Lots of different kinds of things. So in SciFi, SciFi is a package like NumPy. So there is a module called signal. and then you import say square, SQUARE. Okay, so you import square. Square is a function, it will generate square wave. So not wave, stretch. And x equal to np dot linspace, and then say -10, +10, and say 1000. And you write plt.plot x square, and then you write x. So you write, do that. Okay, let's run. It's not coming. Why it's not coming? It will come. Ah, it's coming. It was. So this is your square. You can now go here. You can now go to the square function, because square function is from SciFi. It is nothing to do with matplotlib. You go there and you take the help for how the square wave you can manipulate. How can you reduce the width and the height and etc. etc. All these kinds of things can be done. How you can adjust frequency, etc. etc. And you can also import, say, sawtooth. So you can also write sawtooth. So now you can write run, and you can write the sawtooth. Then you can manipulate these as a triangular wave, right? Just write 0.5. So you see the Python is a triangular wave. You can draw a line here. You can draw a line here, plt.ax h line. Okay, and you can check these. So it's a triangular wave. So the see the Python is fun. So you have everything at your hand. Okay, so this way you can generate lots more things, lots of plots from your scientific calculations. The data next I will show for the people who collect the data. They do not generate from any program or from experiment. There are some people, for example, the people are in geography. They go for field work, and in social science they go for field work, and they design their the data set. The questionnaire, and they collect data, and these data they bring home, and then they plot the data, do statistical analysis, and etc., and they finally do some modeling and tell something important to us. Okay, that's very important. So that I can now go here. Okay, let's see. But before that, I will tell you one thing. One more interesting thing, that is, you can actually you can in a scientific community, people do lots of things with. What I was talking about is that the matplotlib is not you don't treat it as a separate plotting software. This is integrated with basic Python, so that whatever you are doing in Python, you is writing a program or whatever, you then write 2-3 lines, and then your plot is ready. You don't have to go anywhere else. So on the itself with with your program, so you write a few lines. So basically, combining everything, you have basically written a Python script or code, even if you try to draw some plot. So that's